For more information, please visit SGMAK Associates website.
Hi, here is another part. I'm calling it part 6. Some more solve problem on quadratic equations. So I'm going to go through maybe another set of 10 problems and go through them. If you have any question, get in touch with us for clarification. So problem number 1, let's say if alpha and beta be the roots of the equation ax squared plus bx plus c equals 0, and gamma and delta be the roots of the equation px squared plus qx plus r equals 0. So two separate equations, roots are alpha and beta, gamma and delta. And suppose d1 and d2 are the discriminants of the equation of the two respective equations. And one more information given, that alpha, beta, gamma and delta, they are in arithmetic progression. Consecutive term difference is the same. It says find the ratio of d1 over d2. It's again algebraic manipulation of some basic concepts. So sum of the roots alpha plus beta is minus b over a. Product of the roots c over a. For second equation, gamma plus delta is minus q over p. Gamma times delta is r over p. Now since alpha, beta, gamma and delta are in AP, so if I take two consecutive terms, the difference remains the same. Beta minus alpha equals gamma minus beta equals delta minus gamma. So we'll be using the difference between beta minus alpha and gamma minus delta. So we convert them into using the discriminant. Beta minus alpha squared is b squared minus 4ac over a squared, and gamma minus delta squared is q squared minus 4rp over p squared. Since alpha minus beta equals delta minus gamma, so if you look at this ratio, what happens is, what you get this ratio as beta minus alpha squared, b squared minus 4ac over a squared equals q squared minus 4rp over p squared. So d1 over d2, the discriminant comes out to be a squared over p squared. You can see the simple algebraic manipulation. Move on. So second problem is a and b, b not equals 0, are the roots of the equation x squared plus ax plus b equals 0. Then what is the least value of this expression, x squared plus ax plus b? So since a and b are the roots of the equation, each one of them satisfies the equation. So you have 2a squared plus b equals 0, and then with the b we get b squared plus b plus ab equals 0. So the least value of x squared plus ax plus b can be written as a part of a perfect square plus 4b minus a squared over 4. So the part of the perfect square, the minimum value is 0, happens at x equal to minus a over 2. So the minimum value of this expression is 4b minus a squared over 4. And if we substitute the relation between b is minus 2a squared, so this comes out to be minus 9 over 4. Okay? I think the key thing here is if a and b are the roots, then each one of them satisfies the equations, each one of them separately. That's what we have used here, and the expression for determinant. So if a, b, and c are in harmonic progression, then 1 over a, 1 over b, 1 over c are in arithmetic progression. So we have 2 over b is 1 over a plus 1 over c, or if we combine 2 over b is a plus c divided by ac. So b is 2 times ac over a plus c. Now the discriminant of this equation, b squared minus 4ac. If you substitute for b, we get an expression minus 4ac times 1 minus 4ac over a plus c whole square. Or it can be written as minus 4ac a minus c squared divided by a plus c squared. So the expression within the bracket is positive, so the discriminant is less than 0. So if a, b, and c are in harmonic progression, then the roots of the equation are imaginary. Okay. Look at the next. Find all the integral values of a, parameter a, for which the quadratic equation x minus a times x minus 10 plus 1, x minus 10 plus 1 is 0. And that equation has integral roots. So we rewrite the equation x squared minus a plus 10x plus 10a plus 1 equals 0. So sum of the roots a plus 10, product of the roots 10a plus 1. Discriminant is a plus 10 squared minus 4 times 10a plus 1. So a squared minus 20a plus 96 equals 0. This quadratic equation has the roots. If the discriminant is 0, then we get values for 12 and 8. Now discriminant 0 makes the roots identical. So for a equal 12, we get two identical roots. A equal to 8, we get two different identical roots. Now we get integer parts. In the discriminant is 0, we get integer values. If if a plus 10 is divisible by 2, a plus 10 over 2 is an integer. So for a equal to 12, we get the value 11, which is an integer. For a equal to 8, we get the value 9. So we get both integer roots. So the parameter values for which you get integral roots are 8 and 12. Next equation, x squared plus 2 times a plus 1 times x plus 9a minus 5 is 0. It has only negative roots. So we got to find the range for values of a. For the negative roots, that means discriminants are if it has a negative roots, then we get. Now let's look at the discriminant first. The discriminant is 4 times a plus 1 squared minus 4 times 1 into 9a minus 9. That gives a quadratic a squared minus 7a plus 6 greater equals 0. It has to be greater equals 0 for roots to be real. Now both roots are negative. That means the product is positive. So 9a minus 5 has to be greater than 0. A has to be greater than 5 over 9. And if you look at this expression, a squared minus 7a plus 6 equals 0, it has roots 6 and 1. So, so for a equal to 6, satisfy both equations, we get both roots are real, and the product and both roots are negative. So the roots will be minus 6 and minus 1 for this equation, and that happens for a 6 or more. So both condition is satisfied. If p not equal p prime and q not equal q prime, and if the equation x squared plus px plus q and x squared plus p prime x plus q prime equals 0, they have a common root. A common root will satisfy both equations. Let that be alpha. So if alpha satisfies both equations, so we substitute, we get two expressions. If we subtract, we get a value for alpha, q prime minus q divided by p minus p prime. Other way is if we can, what happens is if we multiply the first equation with q prime and second equation with q, second equation with first equation with q prime and the second equation with q, then what happens is we can find another value for alpha, and which comes out to be alpha cannot be 0. So the other value of alpha is pq prime minus p prime q divided by q minus q prime. So what happens is the common root has two values, and we are simply finding that through algebraic manipulation. We're utilizing the expression that alpha satisfies both equations. That's all we are doing. If absolute value of x squared plus 3x plus x squared minus 2 equals 0, you got to solve for x. Now, whenever you have absolute value expression, you got to be careful about managing it for both positive and negative value for x. For x positive, this equation is x squared plus 3x plus x squared minus 2 equals 0. And that gives you a root minus 3 plus minus 5 over 4. Since x is positive, only valid root is 1/2. Now for x less than 0, so we have to write x squared minus 3x plus x squared minus 2 equals 0. Now if you look at the expression x squared minus 3x, for x greater than minus 3, for x greater than minus 3, you got to put a negative sign. You got to write minus x squared minus 3x plus x squared minus 2. And for x less than minus 3, minus 4, minus 5, you have the regular equation. So if you solve for them, by solving for them, you get for x greater than minus 3, the root is 2/3, which is good, and for x less than minus 3, the roots are 2 and minus half, so not valid. None of them are valid. So roots of this equation is 1/2 and 2/3. Try to understand the second part. Okay. 4 plus square root of 15 raised to the power x, 4 minus square root of 15 raised to the power x is 62. So solve for x. So 4 plus square root of 15 multiplied by 4 minus square root of 15 is 1. So 1 is reciprocal of the other. So that's why if you substitute the first term as y, the second term is 1 over y. So you get a quadratic with y, and the roots are 61.98 and approximately 0.02. If you solve, you get the value for x as plus minus 2. If alpha beta be the roots of the equation x squared plus 2bx plus c equals 0, and gamma and delta be the roots of the equation px squared plus 2qx plus r equals 0, and alpha, beta, gamma, and delta are in geometric progression. They are in geometric progression. So you have alpha over beta equal beta over gamma over delta. Corresponding, if you take consecutive term, ratio stays the same. So you get alpha minus beta divided by alpha plus beta is gamma minus delta divided by gamma plus delta. We can manipulate that algebraically. Or alpha minus beta square divided by alpha plus beta square is gamma minus delta square divided by gamma plus delta square, and that gives us, using the sum of the roots and product of the roots, we get on one side we get, as you can see, the expression alpha plus beta is minus 2b over a, alpha beta is c over a, gamma delta is r over p, gamma plus delta is minus 2q over p. So what happens is, based on the geometric series, what you can find that you can find the relation that AC over B square equals PR over Q square. Okay. Because they maintain a ratio alpha over beta is beta over gamma equal gamma over delta. We have a relation between alpha plus beta and alpha beta, gamma plus delta, and gamma minus delta. So what you find that since alpha minus beta over alpha plus beta is gamma minus delta over gamma plus delta, by manipulating that algebraically and using the geometric progression, we can write that we find that AC over B square equals PR over Q square. So that's the relation between those two parameters of those two separate equations. Okay. Last problem for this part. If every pair of the equation x squared plus px plus q, x squared plus qr, rp, and pq, they have a common root. Every pair has common root, then find the sum of the three common roots. So let's say common root for the first pair is alpha, so satisfy both. The second pair is beta, satisfies both, and the third pair is gamma, satisfies both. So you get a relation from the first one. Alpha is R, second equation because alpha beta is P, and the third one is gamma is Q. So some of the common roots will be P plus Q plus R. Okay. Again, go through the problem. If you have any question, get in touch with us. Okay. I'll come back with more material. Bye now. Hi. We are posting materials online. If you have any doubts or any questions regarding the materials posted, feel free to get in touch with us through email. Provide your name, address, school name, your contact information. We also welcome if you provide comments so that things can be improved upon. We also appreciate if you provide any feedback. Okay. So let us know what do you think about the material posted. Okay, bye now.
For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website. For more information, please visit SGMAK Associates website.